Hey everybody, John Grimsmo here in our beautiful Grimsmo Knives machine shop headquarters, HQ worldwide, whatever. Boy, do I have an awesome video lined up for you guys today. We've been filming this for the past like 6 months. It's epic. But first, I have 2 points that I want to make, catch you guys up a little bit. We've been in this shop, let's see, 2 days from today is when we got the keys a year ago. So we've been here for almost a year. And it's gone slow and it's flown by. It's been a weird year, everybody knows that. I'm extremely grateful to be in this shop. Look at it, it's beautiful, it's beautiful. We built this. I'm so happy, so proud. Second point, this machine, our Mori, we've had it for 5 and a little bit years. We just paid it off this last month. It is mine. I own that thing 100% outright. The 5-year lease that we had on it is done. No more payments. So happy, so pumped. So one day I want to do like a full recap of that machine, like the buying process, you know, how we use it, that thing's made us a lot of money. The $150,000 we spent on it or whatever it was is so worth it. So yeah, one day I'll do a recap of that. But for today's video, I want to talk about coolant. I want to talk about specifically how we fill our machines with coolant, because right now we have one machine, those 2 UMAX don't have coolant yet, one of them will, and then the Nakamura, and then the Mori. So we got 3 CNC machines that use coolant, and filling coolant is a pain in the butt. I've talked to a lot of other machine shops that struggle with this too, and it's dumb, and I want a solution. So in my head for the past few years, I've been trying to plan like how to do an auto fill-up station, how to, you know, do we plumb lines throughout the whole shop? You can see ours right there. And how we do that. So actually when we moved in and the plumber put in sinks and plumbing and everything, I had him string hot cold so we can have sinks on that side, but also an extra line for coolant. So I'll get to that in a little bit. So the way we used to do it before, and the way that many people do it, is we used to buy 5-gallon drums of coolant. We use Qualichem 251C, love it. And then yeah, we have this big suction cup, you know, syringe, like huge syringe. We'd pull out a little bit, we'd pour it into either a 5-gallon bucket or one of these Rubbermaid totes, whatever they are, 100 liters I think they are. And then we use this drill paint mixer, put it on a drill and stir it up. Because with the coolant, like water-based coolant, it emulsifies into the oil emulsifies into the water and it turns milky, and you got to mix it up really good. And then we'd have a little submersible pond pump that would pump to the machines, and it was fine. We did this for years and years, and it was just annoying. And some of the machines get really thirsty, and the water, the coolant, it evaporates over time. You can see here in our next gen coolant coalescer, this is what the coolant looks like. It looks like gross milk. But it's water-based, and that water evaporates, especially the more you machine, the more high pressure you use, the more face mills, and like the coolant hits the tool spinning at 12,000 RPM, and it just flies all over the place. So, and then the mist collector sucks all that mist up, and you lose water through evaporation, like a decent amount, gallons, quickly. So like in days, or everybody's different, but it depends on how much you use it. But like we're topping up gallons every couple days or more. I don't even know because I don't do it anymore. But I wanted a system for the company, for the team that makes it easy. And I'm thinking to myself, what's the easiest? What's the end goal? I want to be standing there machining, and I want to grab the coolant gun, and I want to put more coolant in, and that's it. Or what's even easier than that? Automatic float levels. I'm not to there yet. That's like phase next. But yeah, let me show you guys what we came up with. It's a good build, so enjoy. I apologize if that Nakamura is really, really, really loud right now. It's just loud. Those live tools make a lot of noise. We're making Saga pocket clips right now, and there's a lot of milling. Sorry, but we're gonna do this. We're in this together. So when it comes to building a coolant system, there's a lot of factors to consider, like where do you get the water from? How good is the water? Do you want to treat the water, reverse osmosis or deionized water? So that's its own little system. And then if you want to transport the water throughout the shop, how do you do that? Do you use line pressure, like water city water pressure and you just run water to every machine and then you're running line pressure? Or do you have a storage tank that you maybe filter the water and then store the water, but then you have to get the water out of that storage tank and then around the shop? So I went through so many different scenarios in my head over the past year, specifically, but also like I've been toying with it for 3 years now, how I would build this. And this year I was eventually like, you know what, let's get it done. Let's do it the way that I've always wanted to do it. Probably cost me, I don't even know, I stopped counting, $2,000 to $5,000 for all the system, all the parts and components and stuff. And then it's done, it works great now. So what we ended up doing, we got from Uline, we got an IBC tote. This is 275 gallons. We got from US Water Systems, we got the reverse osmosis water filtration setup with a inline TDS meter, so you measure your total dissolved solids. You know how good the water is coming in and how good the water is coming out. So city water pressurizes that, and then it literally goes through this little white line here. This tank is now full of reverse osmosis water. Very, very clean. I think our TDS was like 14 or something. 144 in. Maybe it's not running right now, but it's measuring 1 coming out. That's incredible. That's good. So that tank is full of clean water. That's fantastic. Fun fact, the first time we installed it, we forgot to put the actual filters in, so it didn't do anything. And we're thinking we have 200 gallons of like clean water here, we're using it, it's all cool, we're all excited, and then we realized it's not clean water because we actually measured it. So we had to dump all that water or use it for something else, and that was dumb. But then, once you have a tank, how do you get the water out? They have valves on the bottom that you can attach to. You can have stuff coming out. But what we chose to do is we got this amazing Grundfos pump. It's like a water pump. Here is the part number if you're curious. This thing was 900 Canadian, I think. I think you can get them for about 700 US. This is a, I forget the word, self-priming pump or something. No, that's the wrong word. There's a bladder inside and it holds the pressure. It holds the line pressure. So it's suctioning the water from here. Notice how we have quick disconnect connectors here, the cam lock connectors, amazing. And then we just have a piece of, it's actually shark bite tubing drilled into the top of the tote, and then within, you know, 1 inch of the bottom, and then angle cut. So it's actually touching the bottom with the angle cut. Sucks the water out, and then it holds line pressure. So it's holding, I'm not sure, we haven't put a pressure gauge on it yet, but it's probably holding 40 PSI, give or take. And then as the system, as we use a coolant gun, this has instant pressure, which is the best. And then you can hear the pump turn on, and the pressure fluctuates a little bit as it tries to keep up, but it has no problem keeping up, and it's amazing, and it's the best thing ever. All right, guys, so let's go back in time 4 months, back to when I first printed this and built the project. I filmed a lot of footage back then. Here you go. All right, I just printed the lid. Turned out super duper good. And I printed some spots here. What I want to show you guys is how I'm going to do threaded inserts and screws in this thing. So I got these inserts from McMaster. I got a bunch of different kinds. These are little 440 ones. These ones are M6. And then I got some M4s that I'm going to use right now. And they're so they're barbed on the outside and sort of hexagonal, but threaded on the inside. And some of them will have a little lip on the top. And the first time I used these, when I made the black container, which is now kind of not useful because I did it wrong. The holes printed a little bit undersized, and then I had to drill them out a little bit bigger, and then I pressed them in with a little hammer. I didn't like it. This way, however, I actually read on the McMaster website, and I love this way. So I've got a few more to do, and I'll show you how I do it right now. Go. Okay. Oh, you can see the internal pattern of the infill. That's awesome. Okay, so I'm pressing in these M4s into those two little holes right there. That's where the E-stop is going to mount. I'm just going to set them on here. And you can see that they're, it didn't print all the way around. It printed a little, there's a little gap in the middle there. I don't really care. It's fine for what I'm doing right now. Okay, so I've got my Weller soldering iron right there. Just gonna take my soldering iron tip, and I'm gonna use the soldering iron tip. I'm gonna heat up the insert until it's hot. And this is 3D printer plastic, so it's literally made to melt at a low temperature. And then look at that, it's falling down already. It's falling down, it's melting its way down. I can get this thing perfectly flush. And then just let it cool off, make sure it's straight. Do the next one, ready to rock. This works so well. I love it. And because the insert holds a lot of heat, it actually takes quite a long time to cool down by itself, but you just leave it, make sure it's straight. Done. I didn't even know I could do this. This is super handy. The print was bulging where I pressed in the things, so I'm just smoothing out the hole now. That is so cool. I might be screwing up my soldering iron tip here, and I'm aware of that, but we'll see. Okay, E-stop, test fit, yes. So I got this E-stop from automationdirect.com, or maybe McMaster, I can't remember. I got a bunch of stuff from both places. The two mounting screws that it uses, for some reason, they don't go like this, they go like this. And I think, I don't know, they called it like secure mounting option or something, but it's super annoying to actually mount to something, having the screws go like this, because you can't, how do you accurately drill and tap angled holes? So I basically drilled through the threaded angled holes so that the screw now goes straight through, and now it threads straight into those bushings. So it's a little wonky, but it seemed to work fine. So now I have a mounted E-stop. You can see the threaded bushings in there, and then the backing, and then the actual switch part gets screwed into the back here. And these are usually set up so that you can have two switch circuits if you want. See, this one only takes half the space. You can have another one here. I just bought the single circuit because that's all I need right now. And then I've got indicator lights that are going to tell me stuff. Going in right there. Look at that. Oh yes! I actually printed this thing. I've got a little bit of video. I printed it straight up and down like this with a little bit of support here, and it's like an 8-hour print on a 0.35 millimeter setting, and it turned out so good. So we got power indicator. Basically, the E-stop is going to be our on and off switch. So if we want the system off, if we want it off for the weekend, when we go home, whatever, off. The power light will go off. Turn it on, power light will go on. Now the system is live, it's hot. All the float sensors and all the pumps and everything will work automatically. When it's on, the first solenoid should be open. That's the backup solenoid. Unless the tank is completely overfilling, then it will shut off. It'll shut off the first solenoid. So this light should always be on with the green light, unless there's an emergency. And then the second light will turn on when the IBC tank needs water. When it goes, oh, I need water, that solenoid opens, water comes into the RO, water fills up. When the float valve turns off, this light turns off, the solenoid turns off, and then the RO turns off. And then it should just keep the RO tank full. So here's my mess inside the container. I'll clean it up as good as I can as I go along. I 3D printed a DIN rail that's gonna screw down to some brass threaded bushings that I put in there. DIN rails are cool, I've never used them before really. But these guys basically click right on. So a DIN rail is a standard, super standard size. Done. On. The first rail that I printed turned out too small, so I kind of, yeah, this one turned out too small, so I had to make it again. No big deal. Just scaled it up a little bit. So I have a relay for solenoid 1, a relay for solenoid 2, and a fuse will go in here to protect the circuits and protect the wiring and stuff. And then I have solid state relays. I really only need one. It's going to drive the pump, the coolant pump, which I'll get to. It's awesome. It's just another DIN rail, and then these are my input-output. These are for the sensors, and I actually wrote on there, input 1, output 1. That side, and then this side will be power in from the wall and power out to go to the pump, and a couple extras just for future proofing. And I pressed in more of those, I melted in more of those threaded inserts. It's good. First test. We have progress. It's dimmer than I expected. It's fine. They're cool. They're 120 volt LEDs. Normally LEDs are like 5 volts. So whatever's going on inside the circuitry of that little tube steps it up to 120 AC. Alright, so I've got my electronics enclosure. I think it's all buttoned up on the inside, and it's all wired up, and everything's good and fused and relayed and awesome. Let's take a look. Alright, so starting with the outside, we got our indicator lights, we got the e-stop switch. It comes open. I routed all the wires into one little pigtail, and it might look messy, and it's as clean as I could do without getting crazy into cable management. And I have a lot more respect for cable management every time I do something like this. And forethought and planning, I didn't draw this out, I knew what I needed in my head, so I just kind of made it happen. But inputs and outputs here, they string this way, some of them go to the LEDs, some of them go to power. I'm using these excellent Wago connectors. They're so awesome. So you click it up, and then you click it all the way, and now there's like a cam lock thingy on the inside. So you put your wire in, and you pop it down, and the wires don't come out. So I've got a 5 block here, and I also got some 2s and some 3s. I really just used the 3 5 blockers for my ground, and then the 2 power wires for 120 volt AC. So those are kind of all split together, and then I have 2 relays. I really only need one of them. This is going to turn on the Grundfos coolant pump, and then I have a fuse here with a 2 amp fuse, which should be enough to drive the solenoids. We'll see, I might have to go higher in fuse. And then 2 little ice cube relays. These are going to turn on solenoid 1, solenoid 2, based on inputs from the float sensors, which are right here. These are the float sensors. So when it's down, it means there's not enough water, so it turns the pump on, and then when it's up, it turns the valve off. And then these are the solenoid valves. I got these from McMaster. But I want to get all this to the point where next week the guys can plug it all in and do all the plumbing side of things and figure all that out. So last few things I have to do is I have to finish wiring up the power incoming and power to the pump, and then signal wires from the float switches to the unit, and then from the unit to the solenoid valves. Shouldn't take me too long. Actually had a lot of fun with this project. Maybe I don't need the distraction right now because I've got a lot of things on my plate, but boy, I love diving into these projects. I love seeing it through to the end. I love I've been thinking about this for years, literally. I've wanted this, and this will help build the system for the autofill system that I want to make next. This is the step one. Yeah, this has been really enjoyable for me personally. You know, the business is running great. I can take a little bit of time and do this. This is going to help grow the business anyway, so I'm very happy with it. Oh, check this out. It's on. It has power, I have signal, and I have output. I have my solenoid wired up. My quick and dirty wired it up with the Wago connectors. I will do it better than this, but this was awesome to test. So I have, check this out. This is my float sensor. So right now it thinks the tank is full. So it shut off the solenoid. I assume you can hear that. It's quite a loud click. Yes! So right now the tank is full. When this drops and the tank is empty, light goes on, solenoid clicks open. Oh yeah, this works! That makes me really happy. It's actually very fun and satisfying. Where's my case? Yes! Alright, so now I'm just gonna more permanently wire up the second one, because I'm having a double redundancy system here. I don't need water leaks. I don't need it overflowing. So it's gonna have normal fill, and then if that breaks for whatever reason, it's gonna have an overflow shut off. So there'll be two float sensors, normal and overflow, and then two solenoids for normal and overflow. And it should be perfect. Inside the valve there, you can just see the piston move. I thought it would have been a bit more, I don't know, travel or something. A bit more dramatic. Alright, I've got my solenoid valve. I've got the 3 wires crimped properly and then heat shrinked, and then I am sleeving over some Tech Flex. That stuff. I used to use this all the time on my cars. It just makes the wiring harnesses look amazing. And look at that. So I'm just kind of pushing it over the connector. Luckily, this 1/4" stuff fits perfectly over the connector. The funny thing about doing this is you want to put this on, you want to have heat shrink on each end so that it doesn't fray apart, but you got to remember to put your heat shrink on the tubing, on the wire, before you've spliced your connections on, otherwise you can't get it on. So I've had to cut quite a few connectors off today, because I'm like, oh, I forgot the heat shrink. So, almost done, very much almost done. Fun little fact about heat shrink tubing, there's lots of different kinds, but for this conversation, there's 2 kinds. There's your regular 2-to-1 expansion ratio or contraction ratio, which is like your normal stuff, which is actually this one. It's called 2-to-1. And then there's this other stuff that is 3-to-1. I greatly prefer the 3-to-1 because it actually has a glue on the inside. So as you heat it up, not only do you get more shrinkage, but you have this glue inside that kind of seeps into everything and makes it watertight and just makes it better. And especially with the Tech Flex that likes to fray, the glue gets all in there and makes it nice. I like the 3-to-1. So here you can see the fraying on the end that I was talking about. So I'm gonna give it, you know, maybe about 1 inch there, make that section nice and tight. Do the 3-to-1 gluey stuff over it, and then you just hit it with a lighter. A little heat gun or I don't think a blowtorch would work any better because it would be too hot. But I've used a hairdryer before, a heat gun. You kind of go all around, make it nice and evenly hot. Then that glue seeps into the mesh fabric of the TechFlex, and then we're good to go. And I'm done for the day. Super late night. But I got the fully system test. I don't even speak good English anymore. It works. It works. I got both solenoids set up. I got both valves. Not valves, float switches. Works awesome. So next week the guys can put this all together. They just got to do all the plumbing, all the hookups, all the ball valves to shut off, all the safeties, all the hook up the RO system. There's a lot to it. So we'll get some footage of that, and then maybe I can wrap it up once I get back. Back from vacation, feeling great, feeling pumped to get back at it. Before vacation, I wired these up, and at the end of my vacation, I realized I did not install the little thingies that will mount it to the top of the tank, the bulkhead fittings. So I had to actually cut these lines and redo them and splice them back again so that I could install these things. So I just did that. Works great. So what I also did, I'm pretty sure by now you guys have already learned all about the green box and how we built that. It's been working flawlessly. Like now it's December. I think I was building that in August, so 4 months. And it's just been solid. It's been super, super good. I put little quick knurled screws here so we can access the cap. Here, I'll do it right now. Even though we never really get inside because we don't have to. I can tell right now that solenoid 2 is open, but solenoid 1 is closed. All the wiring and stuff that I put inside is working great. Everything's solid. It's just good. It just works. So in here is where we put the float level sensors. So we have, what I wanted to do, I wanted to safety proof this as much as I could. So we have, I thought I would need a low level, but we don't need a low level. We just need 2 levels. That is, so as the water fills up, it stops there. This is the everyday, like, I'm full. And then this is the holy crap, I'm overfilling sensor. So it's a double redundancy. And if both of them would have to fail to have a flood. And I like that scenario. So what we did is we have these inline, 2 inline solenoid valves. One is, how would it work here? I think your holy crap one is always open. And then your daily use one turns off when it's full, when it needs to be used. Yeah, so when the holy crap sensor would trip, this would close, and now you'd have double failure redundancy. And it works. It just works. It works great. It's so awesome. And then because now we have a pressurized system, we have all the shark bite lines. This right here is our coolant lines. We trust it, but we don't want to, overstep our boundaries too much here. So every night when we go home, we, shut this off, and then that's all there is to it. So now the pump will never turn on. It'll hold line pressure, but only so much as is in there. And then now it's on again. Oh, I can hear it turn on. So it's quiet. Pretty quiet. I don't know if you guys can hear it, but it's awesome. So it knew that I need a little bit more pressure, so it's gonna go, and then it just shut off now. So that was on for like 10 seconds. Amazing. So Grundfos puts reverse osmosis water through another cam lock quick disconnect clamp through, we probably have 12 ball valves throughout the whole shop, maybe more. And then it goes to here. We have 1 T coming down to just a hose filter. So we're using reverse osmosis water now, because so far it's just water. We're using that for the ultrasonics. We're using it for, I think, just for anodizing as well on the other shop. Works awesome. Gives us nice, clean water. I decided to go with reverse osmosis and not the next step, which is deionize. Because from the research that I did, deionize is possibly too clean for what we want. I don't know. It didn't seem necessary. I figured I can always add it later, and I haven't had the urge to add it yet. So from there, Another valve, because it's off right now because we're not using it, goes to here, goes to our Mixatron unit. Mixtron. This is an Italian-made, beautiful piece of mechanical equipment. There's no wires, no electricity, no nothing. It is pressure activated, and here you can adjust your bricks. So you unlock it, screw it down, it suctions down there from our 55-gallon drums of QualiChem coolant. And what that Mixtron does is it emulsifies the coolant for you. You say, I want 8% of coolant, you adjust it to 8, and it sucks water. It uses water pressure to suck up coolant, and then out comes your coolant, your white mixed liquid. So that goes there, down to the PEX line, and then throughout the whole shop. One line goes here to the Nakamura. You can see it coming down off of our Unistrut. Also notice no wires on the ground, no hoses, no cables. I want a clear path going all the way through the shop, behind all the machines. Oh, so good. And then how we're using this. We're using this, comes down, another check valve here. And then for now, we just have the hose wrapped around like that. And then we have these coolant guns we got from Misumi. I'll try to provide a link in the description if you're curious about these. I like them, I don't love them. There we go. They work good, they leak a little bit, so we always have like rags that we hang it on right there. But they work good. And in a minute I'll pressurize the system, I'll show you guys how it works. One thing we really noticed was if we just screw a barbed fitting into the coolant gun and then you just hose clamp on the thing, the tension of the coiled hose makes it really annoying to aim and twist and stuff. So we put a quick disconnect fitting here so that you have this natural twistability, so you can move it around and aim it and not feel like you're always tied up with the hose. So that was Angelo's idea. That's really good. We got those from McMaster. Some of them are meant for like garden hoses. Some of them are meant for mold making industry, for molds. I'm not sure what the difference is, but they work great. And yeah, so we got one here. We've got one prepped for one of the UMAX is going to have coolant. One's going to stay air, but we don't need it yet. And then we have, yeah, the line just keeps going this way. Right there, right there, right there. It tees up here, another ball valve. Tees up. This is the one that goes up and over and across. One side goes to the UMAC, the other side goes to the Kern. And then another T goes this way to the Mori, where I'll show you guys. Boom. We got the same thing coiled up right there. So a couple continuations I want to do on that. I don't like how it's on the wall, so we're going to mount it. Either use that unistrut or add another unistrut going out to the machine. We've got our setup table and our new toolbox right there where all the end mills and tool holders and stuff are. But what I really want is as you're here using the machine, so you're like, man, I'm using the machine, I'm cleaning it. It's actually done right now, so I can open it. So just like how you have your air gun right here, and you're like, psh, I want the coolant gun here somewhere. I want to be able to just grab it, do that. So it serves two purposes. Actually, now's a good time. I'll show you guys how it works. It not only adds coolant to the machine, but it also lets you wash down all the walls, the features, the gross stuff that just accumulates on the sides, the chips that get stuck in the back corner. It just lets you keep the machine fresh and clean, and it makes a huge difference, and it helps, and it's also topping up coolant at the same time. And just works great. Just works great. So I also got, check out this bad boy. I got this from McMaster. It was like $180. It's a very expensive water gun. I haven't even tried it yet, but this is on my to-do list. Just need to add a fitting here. This thing is cool because it's not an on-off switch, it's variable, and I think it goes from beam to cone, depending on how much you squish it. So I'm very much looking forward to trying this. I think it'll be awesome. But it is, one thing Angelo noticed is he didn't like how the trigger was so long, because, you know, normally if you just want to use 2 fingers, you're going to squish your other fingers, and that's very annoying. That was just his first impressions of it, and he's not wrong. But that's exciting. And then lastly, so the coolant line goes over to the kern, another ball valve on the wall. Coolant line. Got the red hose here. These 2 black hoses are the water chilling. There's like 3 kinds of coolant in the kern. It's the water cooler. It keeps the machine cold. But we've got a red hose here following these hoses, and then it goes over there to the paper band filter and coolant unit, to right here to another ball valve. And then this guy is just simply a hose. Just a hose. So assuming all the ball valves are open and assuming the system is on, which it's not right now, I just open that ball valve and then I have coolant to the machine. I still have to remember, as every machinist ever has forgotten, I still have to remember to turn the ball valve off when it's done. So it is still a manual operation, but we are bringing the coolant to the need, to the source. And that is the most important thing for me right now, as opposed to lugging buckets around or hoses or mixing with the drill, or all that garbage is done. So this was a big install to do, a lot of stuff, a lot of PEX line, a lot of shark bite fittings, a lot of the IBC tote and that whole electronics project and the float levels and the Mixotron and the RO system. Like, it was a big project, and I'm super glad we did it. It's like we don't even think about it anymore. We just add coolant, and every now and then you got to tweak the concentration level. But it just works, man. It just works, and that's what I love about a good plan, is when it just works, you're just happy about it. It just works. So yeah, I'll still show you guys how the system works, but to kind of recap, phase 1 is complete. It's in use. We're using it on every machine. It's amazing. It's just, you don't think about it anymore. You don't think about having clean water. It's just automatically topped up. You don't think about, as long as the 55-gallon drum of coolant doesn't go empty, we check it every now and then, it's good. As long as your RO filter, like, there's still maintenance you got to do, make sure it's good. You make sure you don't overfill the machines, etc., etc. But for phase 1, I'm super duper happy. It's amazing. I recommend it to all my friends, and it's great. Phase 2 is to automate this. It's totally possible, but it adds a whole nother layer of scariness. All we really need is float levels in each machine tank, so that each machine knows what the full level is, what the refill level is, and what the holy crap level is. And extra solenoid valves. You can even have moisture sensors on the ground that shut off certain solenoids. I'm conscious of not overcomplicating it and not making it too error prone, because an error equals coolant all over the floor, which is the last thing you want. But I also want to automate this stuff, and I want to make it epic, and I want to make it like safe and reliable. And you know, some people even have the water sensors send you a text message if there's a leak between the hours of, you know, the dark hours or the weekend or something like that. Like, I don't know. There's ways to do this DIY that are completely possible, that are as safe as you can be, that need to be investigated. And I think I'm almost there. But the other point is that each machine might require a slightly different concentration of coolant. Some machines, like the lathe, the Nakamura, evaporates coolant quickly. There's just so much spinning and going on, and like mist and moisture and stuff, that we have to top up that machine the most. Meaning the concentration requirement might be different than what the Mori takes or what the Kern takes. So the best way I can think of to do it, yes, it's more expensive, but it's to put a Mixotron unit on each machine and to send RO water through the whole shop to the machines. And then we could actually do an RO water setup to the ultrasonic machines, which are right there. that'd be great too. So if you have RO water going to each machine, and then you have Mixtron, like I'm looking at the Kern right now where you're standing, Kern right here. If I had a Mixtron here somewhere, and then float valves in the tank that tell the Mixtron solenoids to turn on and off, then you'd have coolant automatically topped up always, and it'd be epic. It'd be like so cool. The fear with that, as we found sometimes, like with some machines, when the machine's off, say the level is here, and then the machine turns on, and it uses coolant, like it's through the lines, it's through the system, it's in the chip conveyor, the coolant is busy. And then you shut the machine off and the coolant drips and drains and the coolant tank goes back up, 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 up. So here's your like off level, and then maybe here is your running level. And you gotta make sure when it's running, you don't fill it to the top, because then the second you shut the machine off, you will flood. I've done that with the Swiss, with oil. It is a bad day. So if I built a float system setup in the tank, I'd calculate that in somehow. I don't know, make them adjustable, and you just figure it out. That's not a problem. It's just something to keep in mind. Yeah, don't fill the machine to the top when it's running. Bad idea. But I mean, as far as I can remember off the top of my head doing this video, those are the main problems, variables, you know, theories to keep in mind while doing a system like this. And man, I'm so glad that I did it, because it's awesome. It suits everything we're trying to do in this gorgeous shop that I'm so proud of, and the team has worked so hard on, and it's what has to be done. It just has to be. So yeah, I'm glad we're there. Okay, let's get into some demo, and then Fraser's gonna shoot some sexy B-roll footage in 4K of stuff. I don't know, he wants to. He got a new toy, he got a new camera to play with, and then yeah, and then we'll wrap this thing up. Okie dokie. Fun fact about my role in the company as the owner, the founder, the president, I'm starting to step back more. So there's things I don't do anymore, which is kind of weird. I don't touch that machine anymore. It's mine now, like I talked about. I don't touch it. That's fine. I love it, but I'm gonna pretend like I know what I'm doing on this machine. So let's go around. Let's turn the water pressure on. I'm gonna turn on the water system. Yeah.
Do you want the water in? Or?
Yeah, I just want to use it and like show it.
I'll put it over there.
Okay.
So put it back to glass.
Yeah.
You need to put a unistrut up, and it's going to be fed down and around.
Yeah, that makes sense.
So you walk over, and you don't have to do this, because this is...
It's annoying, right? It works fine, but it's like,
yeah,
we can do better.
Yeah, we're not there yet.
Yeah.
So,
okay.
Yeah.
And it's like, what is it, 3/8 ID hose? So it's heavy. It's got some...
Oh yeah, it's heavy duty hose. Part,
yeah.
It's not going to break or anything. We're good.
But it coils and it tangles, and that thing does drip, right? Like.
So the swivel allows us to turn it, as John talked about.
Yeah.
For molds, for cooling. So I want it right here. That's the plan.
Yeah.
With a little bit of hose, and it's just going to come over that way. Nothing's on the floor.
Yeah.
And then down here, and you got your hose right here. Just go back.
Love it.
Nice. Way easier. So yeah.
Sweet. Okay, let's turn on the system. There's so many ball valves, I gotta make sure they're all on. Okay, system is on. Pretty sure solenoid 1 is low, like I need to fill up, and solenoid 2 is I'm full. No, I forget. It's been a while since I designed that. Okay. Water on, water on. Everything's good. That one's to the Nakamura. I need this one. That one's to the Kern. I need this one. So as you can tell, we're being super paranoid about like keeping it off when we don't need it. But all right. And you can see the spy over there filming his 4K. Okay. Oh yeah. Yeah, with the super heavy gauge hose and without having the swivel here, it's heavy, it's clunky, it's kind of annoying. But it's good. Like, I can easily, with pressure, hit the back corner. Oh, this is so good. It's like I mentioned a minute ago, I don't even get to use this stuff. I just design it and put it into place and buy it all. And then the guys get to enjoy it. Or be spoiled and just think that that's normal. I can feel the pressure changing just a little bit as the need arises, but oh, it's good. See, this is an on-off. There is no there's no modulating this whatsoever. But I like it. I like it a lot. Check this out. Random fun fact. Angelo makes this. He made these before he ever worked here. He's been making this kind of knife, and he's got a couple other designs for a long time. This is, what is it, like triple PVD coated or something?
Well, that's chromium nitride.
Chromium nitride coated, but he's played with DLC, he's played with PVD and all kinds of other coatings. It's good stuff, man.
Yeah, I like the finish.
Yeah. Bet you didn't know that about him, or maybe you did. Also, fun fact: a couple weeks ago, we hired Pierre. Pierre has been awesome. He is running the Swiss now. He's taken it from me. He's doing a killer job. We're making pen parts like crazy, and Angelo and Fraser and Pierre right now have been talking about. We are dumping a lot of pens on the website. Like, it's 2 days to the end of the year. Let's get as many up as we can. You know what I mean? It's good. Things are good. Things are good. I haven't filmed much lately, but I'm having a lot of fun doing this right now. So, yeah, guys, I guess that's it. Yeah. Thanks for watching. It's a fun project video. I like doing projects. I want to educate more, but I've been focusing a lot this year, not on YouTube, but on the business, on the growth, on the products, on the Kern, learning 5-axis, on the Rask, et cetera, et cetera, et cetera. So, yeah, 2021 is going to be a really, really big, good, interesting year for us, and I'm looking forward to it. I'm excited, man. All right, take care. Bye. One more thing I want to add before I forget. When I was at Kern in Germany, looking at buying that bad boy, which I actually did, which still blows my mind a little bit, what Marv had is he had a coolant gun. They had oil in their machine, which I'm not a fan. Let me wake this thing up. I dropped that towel again. I don't like having that towel right there. He had his coolant gun inside the machine. He had it hooked right here. You gotta watch out for the laser sensor and stuff, but he had it here so that the hose goes through the machine. Like, you gotta watch out for stuff, but that's kind of a cool idea, because it doesn't matter if it drips now, and it's always inside, and yes, you're grabbing a wet hose, but it's here, so it's a neat idea. And what they do on some of the Haas machines is they actually have a hole in the sheet metal where the gun just lives, which I really like that idea. I think it's a brilliant idea. And then it's there. Now I'm thinking about how to drill a hole there and like 3D print some adapter or something. Totally possible. I don't know yet. But 2 other ways to do it.